All right, guys, so we're looking at the second part of section 6.6. This is on page 183 in the Student Journal. So we're trying to solve inequalities now. That's our goal in this part, is to solve inequalities involving logarithms and exponentials. So we already talked about equations. Now it's inequations or inequalities. All right, so on this first one, we're going to treat it as if it's just an equation to start with. So we're going to think of it as just log x equals 1/2 to start with. So I want to rewrite this in order to solve for x. I want to rewrite it as an exponential. What's the base? So it's going to be 10 to the 1/2 equals x. Well, that means then that x is equal to radical 10. All right, and so now we want to continue by figuring out how should these signs go. So to figure out how the signs go, we're just going to kind of leave that open here. It's going to be x and radical 10. And how do they compare? All right, well, this is what we're going to have to do. We're going to have to go to the calculator, put each of them in, 1 into y sub 1 and 1 into y sub 2. So I'm going to put in log x. And then in the other one, I'm going to put in my original problem of 1/2. I'm going to do a zoom 6. And here's the way it looks. Okay, so can you see what we're trying to do? We're trying to solve for the values of x that would make this true. What values of x keep this below 1/2? The little region that works is just right in between there. So why is that? Well, algebraically, we have to think about it. Going back to the original, what is the domain of that? X must be what? Greater than 0. That's the domain. And you can see from our picture here that in order to keep this function lower than 1/2, we have to go to that point of intersection. So look at what that point of intersection is. It's 3.162. Well, that's the same thing as radical 10. 3.162. Okay? So what that means then is that the x value that we come up with must be less than or equal to radical 10, but greater than 0. That's the way we would write this in interval notation. In inequality notation. In interval notation, we'd write it 0, comma, radical 10, bracket. Okay? So, let's see what the pattern was here. So look what happened. We had log x less than or equal to radical 10. And then it still ended up being a less than that value. But here's where people get confused, because do you see how if I do 10 to the 1/2 and I keep that sign like that, then it looks like x should really be greater than 10 to the 1/2, but that's not the case. X must be less than or equal to radical 10. Okay? All right, but I like using the graphing calculator just to double check all that. So solving this one, we have 2e to the x is going to be less than 6. What do we do now? Divide by 2. E to the x must be less than 3. Okay, before we go any further, let's see. Are there any restrictions on the x? Can x be negative? Yeah. So there's no restrictions here. We can use anything. All right, so now to solve this for x, we have to rewrite it. We have to do log base e of 3, and we're going to think of it as equals here for a minute, equals x. That's what we get. But what's another name for log base e of 3? Natural log of 3 and x. Now, how do you think this is going to look? Is it still going to be pointing in the same direction? Do you think x is going to be greater than natural log of 3? You think that's going to be the solution? I don't know. Let's see. So you go to the calculator. You're going to put in 2e to the x plus 1. We're going to put in 7. We're going to do a zoom 6. Here's 2e to the x plus 1. Here's 7. We want to know, where is this curve below 7 for what x values? Is it when x is going to be greater than natural log 3? Here are the x's that are greater than that point of intersection. Is that where the curve is below 7? No. So it has to go like this. It's actually going to be that x must be less than the natural log of 3 for this to work. Any of these x's are going to make it true that it's going to be below it. See, this point right here is natural log 3 if I were to find it. So that's 1.0986. And look at what the natural log of 3 is. 1.0986. You with me on this? So it's a little tougher than the other ones, but that's the way we would write it as an inequality. In interval notation, we would put negative infinity to natural log 3. Both of those answers. Now, I prefer that you use exact answers. The directions on your test will either say approximate, and it'll tell you where to round, or it'll say exact. When you do this assignment on big ideas, they never use exact. They always round. And that gets a little bit confusing. They also never use interval notation. They only use inequality form. So just some things to keep in mind. All right. If your parents buy juice for your graduation party and leave it in their hot car, when they take the cans out of the car and move them to the basement, the temperature of the juice is 80 degrees Fahrenheit. The room temperature of the basement is 60 degrees Fahrenheit, and the cooling rate of the juice is R equals 0.0147. Using Newton's law of cooling, how long will it take to cool the juice to 63 degrees Fahrenheit? And it says you can see the example to see how to do it. But we just did this because you guys asked to see this problem. So tell me, what am I going to plug in for T? 63, right. That's what we want the temperature to be of the juice. What are we going to plug in for T sub O? 80, that's the original temperature of the juice. Minus T sub R, what's that going to be? Good. And then e to the negative 0.0147 t, and then plus, and then what am I going to put? 60 again. All right, so what do we do to solve? Karen?
Subtract 60.
Yep, so I get 3. Might as well go ahead and do this too, right? Kaylee, what now? I want to get this this stuff all by itself. Divide by 20. You can always divide by that coefficient of e, or the coefficient of the base. You can't divide by the base itself. 3 over 20 is 0.15. I'm going to write it as a decimal. All right, so now think about how you rewrite that to solve it. Karen?
It would be natural log 3/20 equals negative 0.1417.
That's good. Okay, and so now to finish it, now this wouldn't make sense to write as an exact answer because you'd never say, hey, the answer is natural log of 0.15. So let's just get an approximation here. And it's 129.1. You may remember, is this Newton's law, is this in minutes or hours? Minutes? So a little over 2 hours. Yeah, that one makes sense to be days or something. All right, let's finish these up. Okay, solving a problem like this. This looks pretty complicated, but here's the way we can do it. We're just going to think of this as being a to the b equals c. So remember how if we have a to the b equals c, we can rewrite that as log base a of c equals b. So here's a to the b equals c. All right? So we're going to have log base 3 of 5 to the 2x minus 5 equals, see what I'm doing here? A to the b equals c becomes log base a of c equals x minus 2. Now, you might be thinking, how is that helping us? Well, what can I do with an exponent? What can it now become?
So multiply, add it to the front.
Yep, it can come down as a coefficient. So now I'm going to have 2x minus 5 log base 3 of 5 equals x minus 2. All right, well now this would have to get distributed. So I would have 2x log base 3 of 5 minus 5 log base 3 of 5 equals x minus 2. Now, to solve for x, I have to have the x's together. So I'm going to have to take the x over here, and I'm going to have to take everything else over there. Right? So watch this closely. I'm going to have to take the x over here, and this is going to have to go over there. So I'm going to have 2x log base 3 of 5 minus x equals negative 2 plus 5 log base 3 of 5. Do you guys understand how I'm doing that? Now, if I want to solve for x, I'd like to be able to subtract these two. Okay, but it's kind of hard to subtract them the way that this is. So if I can't really subtract them, I might be better off just factoring out an x. If I factor out an x of this term, I'm left with 2 log base 3 of 5 minus, what's x divided by x? 1. Okay? And now what do I do just to get x by itself? Divide by that, right? And that would be the exact answer for x. Those are probably the most difficult type right there. Now, let's talk about how you would get the approximate answer. Well, I can just type this in. Negative 2 plus 5 math log base 3 of 5. And I have to put all of that in parentheses because I want that entire thing, this entire thing, has to get divided by that entire value. So now I do divided by parentheses 2 log base 3 of 5 minus 1 on the outside. Okay, that's how we type it up. All right, and so now we push enter, and there's what we get, 2.75, or 2.76 to the nearest hundred. So you will have a couple of those to practice. Kind of tough. All right, guys, let's try this one now. Another different type that you're going to have to factor on this one. This 2 right here, this should be an x. Change that to an x. All right, so look at this. We have 3 to the 2x minus 2 3 to the x minus 15 equals 0. This is actually a quadratic, but it's been disguised. When I look at this minus 2 of this, whatever this middle term is right here, that's telling me this problem will be easier if I say u is 3 to the x. I'm going to say u is 3 to the x. So if u is 3 to the x, this first term then is 3 to the 2x. Well, 3 to the 2x is just 3 to the x squared, right? See how 3 to the 2x is 3 to the x squared? So what did I just say 3 to the x is? U. So now what does the problem become? U squared minus 2u minus 15 equals 0. So now we can factor this. And I get u equals 5 and u equals negative 3. But I'm not trying to solve for u. I'm trying to solve for x. So now I have to go back and I have to say, well, what is u? U is 3 to the x. So I have 3 to the x equals 5, and, 3 to the x equals negative 3. Can 3 to any power ever give us negative 3? What's 3 to the 0? What's 3 to the negative 2? I can never get a negative value, can I? So therefore, this is not going to have a solution at all. What about this one, though? It does have a solution. Does anybody know how to find it? Tori? And how would it go?
Log of 3, like the base of 3 of 5.
And that would be our answer. That's our exact answer. If I asked for the approximate, I can do it this way too. Log 5 divided by log 3. Remember our change of base formula? Log 5 divided by log 3? And there we go. There's the approximation. So in big ideas, they're going to want that. 1.46. I wish they would change it so you did exacts. I like exact a lot better, but that's okay. All right, guys, last one. Looking at this one, we have log base 2 of x equals log base 4 of 8x. Anybody know what's wrong with this problem? It was the same problem we had in number 2 in the warm-ups. Marcella? Bases are different. They are. I have to make it so that the bases are the same. I'm not going to mess with this one. This one's fine. It has a base of 2. I have to rewrite this with a base of 2. I can use my change of base formula. The change of base formula says this. Log of c over a can be written as log base b of c over log base b of a. I can make this base anything I want. Okay? Anytime I have, I'm sorry, that is wrong. I meant to put log, I completely messed up the formula. Okay, let's go over here. If I have log base b of c, that's going to be the same as log base, let's call it m, of c over log base m of b. Do you see that pattern? It goes log base whatever you want of c divided by log base m of b. That's the change of base formula. So what base do I want this to have? What base does the other side have? 2. So I want this to have a base of 2. So I would have to rewrite it. Here's my c, here's my b. So log whatever base I want base 2 of 8x over log, what base do we have to use the same as that? 2 of what? 4. Now, I should be able to evaluate something here. Log base 2 of x, can't do anything with that. But what is log base 2 of 4? Just 2, isn't it? So now I'm going to have log base 2 of 8x over 2. How do I get rid of divided by 2? Multiply by 2. So now I have 2 log base 2 of x equals log base 2 of 8x. Do you know how to finish this? What can we do with the 2 out in the front? Karen?
Put it as an exponent?
Yeah. So now I have log base 2 of x squared equals log base 2 of 8x.
X squared.
Yep, x squared must be equal to 8x. So now x squared minus 8x must equal 0. Factor out an x, we have x minus 8. So we get a solution of x equals 0 and x equals 8. One of those is not a solution though. Do you know which one is not a solution? 0, right? Because if we go back here, log base 2 of 0 can't do that. Because the domain is that x must be greater than 0. So that is not a solution, this is a solution. So 8 is our only solution. Okay? You can see the second part is a lot more difficult than the first part. I would really recommend that you work diligently on these problems. Any questions over it? Okay.